Hello friends, welcome to engineering tutorial. So we'll continue our discussion on sensors and transducers. So in this video we are going to start a new discussion which will be on density measurement of a liquid. So we'll be discussing different types of techniques with different combinations of transducers. So this is the first method, which is density measurement using Bellows and Capacitive Transducer. Okay, so the basic operating principle for measuring density of a liquid is basically it is based on the pressure exerted by a liquid column. Okay, we know that when we have a particular liquid in a container and it is at a certain height h, the pressure exerted due to that liquid column, it is given by PL is equal to rho g h. Okay, rho is density of the liquid, g is acceleration due to gravity, h is the height of the liquid column. Now if you see, we have used two transducers here. First is Bellows and then we have a capacitive transducer. So there is a particular reason for using these two transducers. First, we want to measure the pressure because of the liquid column. That will happen through the bellows. Then we want to measure the height of the liquid column. That will be measured by the capacitive transducer. How? We will see to that. Then when we have got these two values, that is PL and H, acceleration due to gravity is known, we can easily calculate the density through simple mathematical calculations. This is the basic operating principle. Now, just in a quick way, we will go through Bellows and capacitive transducers as we have discussed them separately in videos concerning only that. Bellows I have made a separate video. Capacitive transducer I have also made a separate video. So just in a quick way, we will go through it. So bellows are basically primary mechanical transducers. So primary transducers are those which convert the parameter which they are measuring, basically physical parameters or any other parameters, into mechanical movements, to and fro movements, circular movements, displacement, like that. So it is basically the output is mechanical in nature. So in order to convert that into a suitable voltage or current signal, we have to use a secondary transducer which is of electrical nature. Many electrical transducers are available: resistive, capacitive, inductive, LVDT is a common choice, potentiometers are also used, inductive sensors are used, so like that. Because we basically deal with electrical signals of electrical natures, to convert it into a suitable voltage or current signal, we have to use a secondary transducer. Then we connect it to proper signal conditioning and processing circuitry to get us a proper digital output. So bellows are basically, it's a cylindrical structure, okay, having thin walls with a number of convolutions. These circular, donut shaped things, they are called as convolutions or corrugations. So they are designed separately and then they are stacked one above the other and joined. Okay, and this is the two free ends which are present. One free end is connected to the source of pressure and the other free end is connected to the secondary transducer or a pointer scale arrangement. So the basic operating principle is that whenever there is a pressure difference between the inside and the outside of the bellow, the bellows can be either stretched, that is expand, or get compressed because of the pressure difference. So when the outside pressure is high, it will get compressed. When the inside pressure is high, it will expand. So as a result of that, because of that compression and expansion, okay, like this compression and expansion, the free end, which is connected to the pointer scale arrangement or the secondary transducer, electrical transducer, it will give us a proper output which is proportional to the degree of movement of the free end of the bellow, which is again directly related to the pressure difference. Okay, so they are generally made of special metallic alloys which are elastic in nature, rubber, plastic and other elastic material, and the diameter of the bellows, they range from 7 millimeter to 150 millimeter, while the thickness, it ranges from 0.08 millimeter to 0.3 millimeter. Again, all these are depend on how much pressure it has to handle. If it deals with high, very high values of pressure, then obviously large size bellows will be used of larger diameters and thickness, and if it has to deal with small pressures, then smaller thickness and smaller diameter. So the mathematical relationship which governs this whole thing, as I said, bellows are axially stretched or compressed. Here it is placed along the y-axis, so the compression and expansion, it happens along the y-axis. So this is the original position of the bellow. Here it is getting expanded, stretched, and here it is getting compressed. Okay, so everything happens along the y-axis. If it is placed along the x-axis, it will happen along the x-axis. So this axial displacement along the y-axis, due to the pressure difference between the inside and the outside, the differential pressure, that is delta P, external minus internal, depending upon which one is higher, which one is lower. If internal is greater, it will be internal minus external. We want a positive thing here. So that is given by pi Rm square delta P 1 minus mu square by Et into n by A0 plus B0 into T square by Ri square. So these values, they represent this, where Rm is the mean radius, the outside and the external and internal radius divided by 2, R0 plus Ri by 2, the outer and inner radius. N is the number of convolutions or corrugations. Like I said, the number of these donut shaped things which are stacked one above the other, which are called as convolutions or corrugations. Delta P is the pressure difference, like I said. Mu is the Poisson's ratio, then which is lateral strain by longitudinal strain. Then E is Young's modulus of elasticity, T is thickness of the bellow walls, and A0 and B0 are constants which depend upon what type of material which is used for the design of the bellows. So this is for pressure measurement. Then we have is capacitive transducer, which is used for measurement of the liquid level. So again, it is based on the principle of parallel plate capacitor, where the capacitance is given by C is equal to epsilon A by D. Epsilon is permittivity, which is the product of absolute and relative permittivity of the material. A is the cross-sectional area of the two plates, okay, and D is the distance or gap between the two plates. Now here one thing has to be taken care of, that the cross-sectional area is basically the area of overlap, okay, how much portion of the plate, each of the plates is lying one above the other. That is important, not the area of the entire plate. How much area of each plate is lying one above the other. This is called as the overlap area. And then we have is the distance between the two plates. So there are three ways in which capacitance can change, either through change in relative permittivity, okay, relative permittivity of the liquid or whatever in which the whole environment in which the sensor is placed, then the area of overlap or the separation distance. Okay, so permittivity, overlapping area and distance. So we can it can happen through any of these three mechanisms. In this case, we have a float and rod arrangement which lies on the surface of the liquid. So as the level of the liquid changes, one of the plates of the capacitor which is connected to the float and rod, which is movable, it moves. As it moves up and down, the other one is fixed. The area of overlap, it changes. So as the area of overlap changes, the capacitance can either increase or decrease. Here capacitance is directly proportional to the overlapping area. Okay, it is directly proportional. So as area of overlap increases, capacitance increases, and as it decreases, capacitance decreases. Then the second mechanism is through separation distance change. So here again, the movable plate is connected to the float and rod arrangement. So as the liquid level changes, this movable plate, it moves up and down. As a result, the separation gap, the distance between the plates, it changes, it either increases or decreases. Here capacitance is inversely proportional to the separation gap. So as the separation gap increases, capacitance decreases, and as it decreases, the capacitance increases. Okay, inverse relationship. Then the third way is through permittivity change. So here what happens is that in the whole thing, in the container, along the walls of the container, the capacitor plates, the sensor plates, they are connected. So as the liquid level, it goes up and down, the medium between the two plates is filled with the liquid, which leads to change in permittivity. Okay, see, in this situation, this medium, okay, this medium between the plates of the capacitor, it is filled with air, absolute permittivity. Okay, but in this case, this medium, partially almost, it is filled with this liquid of, let's say this liquid has a relative permittivity epsilon r. So here this equation will come into play, epsilon 0 epsilon r, whereas when it is filled with only air, it will be only epsilon 0 a by t. Okay, permittivity of free space, because relative permittivity of free space, that is equal to 1. Okay, so three ways in which capacitive sensors can be used to measure the level of the liquid. So basically we have a series of capacitive sensors which are placed along the walls of the container in which the liquid is present. So whenever the liquid is at a certain level, the particular sensor is triggered and it gives us information about the liquid level in the container. Okay, so here the basic principle is that the bellows, it is attached to the liquid column. Okay, the bellows is attached to the liquid column. It measures the liquid column pressure, which is rho gh, and also if the container is exposed to the atmosphere, the lid is open, then it measures the total pressure. Okay, the sensor measures the total pressure, which is the liquid column pressure and the atmospheric pressure. As the atmospheric pressure at a certain time, it is we can measure it through other means. It is subtracted from the sensor pressure to get us the liquid column pressure, which is equal to rho gh. So from the sensor we get the liquid column pressure. Now if the lid is closed, the sensor only measures the liquid column pressure. If the lid is closed, if the lid is open, this is the thing. In most cases you will find that, well, it depends. In some cases the lid is open, in some cases the lid is closed. So depending on that, you have to make the adjustments, you have to make the calculations. So the bellows, they measure the pressure, liquid column pressure. The capacitive sensors, they measure the height of the liquid, okay, the level of the liquid. So after we have got the height of the liquid and the pressure because of the liquid column, now we can calculate the density using this formula. Okay, we can calculate the density using this formula. Okay, liquid column pressure we have calculated from bellows, height we have calculated from capacitive sensor or capacitive, that measurement technique, and acceleration due to gravity, that is a constant, that is known. So density is equal to liquid column pressure divided by product of acceleration due to gravity and level level of the liquid. So this technique or this density measurement technique, it involves use of two types of sensors, measuring devices. So obviously it will be costly. Yes, both sensors, two sensors are involved. So yes, cost is more. Also the installation, the maintenance, everything, the cost of that goes up. It is also very difficult to maintain and install this whole thing. And yes, the design of this whole thing, because there are a lot of parameters involved, as the calculation of one parameter, it depends on the other. Okay, this density, it is measured, it is dependent on the measurement of the liquid column pressure by bellows, which will have its own range of error, and also level measurement using capacitive sensor, it will also have its own, yes, there will be error, but we can manage it. So there will be error, so error management, that also it comes into play. So it has its own advantages, it has its own disadvantages, but still it is a good measurement technique for density measurement, okay, of a liquid column. Okay, so this is all about density measurement using pressure measurement device bellows and level measurement device capacitive transducer. Okay, so let us try to understand this whole thing from a three-dimensional perspective. So here we have is the bellows. Okay, so as you can see, this is the whole elastic cylindrical structure with a number of convolutions or corrugations stacked one above the other, with two free ends, one end connected to the source of pressure, another end free to move, which is connected either to a pointer scale arrangement or a secondary transducer, electrical transducer. So as we discussed, whenever there is any pressure difference between the inside and the outside of the bellow, the bellows are axially stretched or compressed. So as you can see here, these convolutions or corrugations, they either get compressed or stretched. So the free end, which is connected to a secondary transducer, it produces a voltage or current signal which is proportional to this axial displacement, which is again related to the differential pressure, that is difference between external or internal pressure. So this measures the liquid column pressure. Then we have is the capacitive transducer, that has to measure the liquid level. Okay, that has to measure the liquid level. So we have used capacitive transducer. So it can either be through change in overlapping area or change in separation distance, or the you know change in permittivity, which is connected in the capacitive sensor plates connected across the walls of the container. So whenever there is any change in the level, the movable plate which is connected to the float and rod, it can either move in this way, which leads to change in separation distance, which is this second arrangement, okay, which is this second arrangement. So here the movable plate moves up and down, which leads to change in separation distance, or it can either move laterally, sideways. So that will cause a change in the overlapping area. So both of them will contribute to change in capacitance, directly proportional to overlapping area, inversely proportional to separation distance. So once we have measured the liquid column pressure and the level of the liquid, we can calculate the density using the formula density rho is equal to PL by GH, because acceleration due to gravity 9.8 meter per second square, that is constant, that is okay. So this is all about density measurement using Bellows and capacitive transducer. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.